Okay, let's talk about dividing fractions. As I've got it written right now, I can't do this. I can't do 1/5 divided by 9/10. So we use what we call keep, change, flip. So I'm going to keep my first fraction as 1/5. I'm going to change the division symbol to multiplication. I'm going to use a dot. Close enough. And then I'm going to flip 9/10. And it's going to become 10/9. Now this we can work through. Let me lower that a little bit for you. There we go. This we can work through by multiplying straight across. So I'm going to do 1 times 10 is 10, and 5 times 9 is 45. So we've got an answer of 10/45. Well, it's not improper because my numerator is less than the denominator, so we don't have to worry about converting this fraction. We just need to see if I can reduce it. So remember, and again, if you're having trouble with this, watch the video on reducing fractions. But we're going to pick our factors of 10. Again, that's everything that fits inside of 10 evenly without a remainder. If you're doing it on your calculator, that means there won't be a decimal when you divide. So we always start with the numerator. So our factors are 10. And as you were looking through a multiplication chart, some of you have already started memorizing this. But the next factor is 5. And then the next one is 2. So now we're going to divide these factors into our denominator, and we're going to see which one fits. Okay, so we're going to start with that 10, and I'm going to do 45 divided by 10. And you see there, I got 4.5. Is it focusing? Yeah. So it's got a decimal number, so it can't be 10. That's okay. We're going to move on to the next one. Interesting. So we're going to move on to the next one, which is 5. 45 divided by 5. And we get 9. No decimal, went in evenly, so it works. So we're dividing by 5. We're dividing by 5. 10 divided by 5 is 2. 45 divided by 5 is 9. So our final reduced fraction of 1/5 divided by 9/10 equals 2/9. So let's look real quick and talk about how we got there. So again, we started with 1/5 divided by 9/10. We did keep, change, flip. Kept it 1/5, changed it to multiply, flipped 9/10 to 10/9. Then we multiplied straight across. 1 times 10 is 10. 5 times 9 is 45. We have to reduce this, so we wrote down the factors of 10. 10, 5, and 2, and we just started dividing. 10 didn't work, but 5 did, and we got 2/9. Let's do one more just a little bit faster. Okay, next problem. We have 2/5 divided by 1/2. Same thing as before. I'm going to do keep, change, flip. Keep it, change it, flip it. So now I can just multiply straight across like I did before. 2 times 2 is 4. 5 times 1 is 5. So just like before, I need to see if I can reduce this fraction. So I'm going to write down the factors of 4. Very simple. There's only 2 of them. So we're going to try 4, and we're going to try 2. These are the 2 factors that fit inside 4. There's really 3 because of 1, but remember, we never use 1. So now we're going to divide into the denominator. First, we're going to try the 4. 5 divided by 4. We got a decimal number, 1.25. So 4 is gone. Well, let's try the 2. 5 divided by 2. Decimal number, 2.5. 2's gone. Remember, if you divide all your factors and none of them work, meaning every time you divide it you got a decimal number, you can't reduce it. That's it. You're done. Let's take a look at what happens when I do my division problem and I get an improper fraction. Okay, guys, last one. We've got 6/14 divided by 1/3. Just like all the others, we're going to do keep, change, flip. 6/14 times 3/1. multiply straight across. So numerator times numerator, denominator times denominator. 6 times 3, 18. 14 times 1, 14. Look what we have now. Our numerator is greater than our denominator. So it's an improper fraction. We've got to turn that into a mixed number. Remember, we have a video also on how to do that. So I'm going to work a little fast doing it here, because like I said, we have the video already. So I'm going to do 18 divided by 14. When you do that, remember, I only care about the integer, the number before your decimal point, and it's a 1. Next, I do 1 times the denominator. 1 times 14, which is 14, of course. Now I'm going to subtract that from the numerator. Numerator goes first, so that I can get my new numerator, which is 4. And then I bring over our denominator. Still not done though. Remember, this is the problem that takes the longest amount of time because it does have a lot of steps. Because the next thing I need to do is I need to see if I can reduce the fraction part of my mixed number. I have 1 and 4 over 14. I can reduce that 4 over 14. So we need to write down the factors of 4. Well, that's easy. 4 and 2. So now, just like before, and like we always do, we're going to divide those factors into our denominator. So I'm going to do 14 divided by 4, decimal number, 3.5. 14 divided by 2, whole number, I got a 7. So I'm going to divide both by 2, and I'm going to get 1 and 2 sevenths. Yep. Let's talk about one last thing when it comes to reducing, and then we're going to wrap it up. Okay, one last thing. As you can see, I've written down the same fraction. I've got 8 over 12 on both sides of me. People have asked me before, how come we start with the largest factor when we're reducing? For example, in that last problem, we had the factors of 2 and 4. Why did we start with the 4 instead of the 2? Well, the reason is because when we're reducing, the goal is to get it to lowest terms. Lowest terms just means we've reduced a fraction using the small, and we've left, I should say, the smallest numbers we can. So let's take a look at 8 over 12, and let's list the factors of 8. So the factors of 8 are 8, 4, and 2. So when we're reducing this, we're going to start with we're going to go from smallest to largest. So let's start with the 2. Well, if I divide both of these by 2, 12 goes into 2, or I should say 2 goes into 12 6 times. 12 divided by 2 is 6. 8 divided by 2 is 4. Cool, we reduced it. Okay, now let's do the same thing over here with 8 over 12. But instead of starting with the 2 this time, I'm going to start with the 8. Now, if I divide 12 by 8, it's not going to work. You're going to get 1.5, 1.5. So let's go on to the 4. Divide that by 4. Divide that by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So take a look at what we have here. I've reduced both problems. But in this case, when I use the 2, it reduced to 4 over 6. In this case here, when I reduced by 4, I got 2 over 3. This is the one that's correct because it's in lowest terms. Yeah, this one's right too. But when we talk about reducing, again, we want lowest terms. If someone was to ask you, would you rather have 4/6 of something or 2/3 of something, well, they're equivalent. But again, I was able to use smaller numbers when I reduced this one. That's why 2/3 is the final answer to 8 over 12. So something to remember, this is why we start with the largest number. Because if I start with the smallest number, yes, I might be able to reduce it, but it might not be in lowest terms, right? As always, if you have any questions, just let me know and I'll see y'all later.